take a look here at lesson 12. Now, again, we are going to be going through and identifying all kinds of postulates, theorems, definitions, and again, make sure that these get into your little book. So this is one of the things that you should have in there. Now, I realize that when you're looking at these things and you see converse and regular, straightforward ones, that you think they kind of mean the same thing. Now, as I read this, it says if two lines are cut by a transversal, then the horizontal or corresponding angles are congruent, then the lines are parallel. What we are able to do with these ideas, if I know that the lines are parallel and it's cut by a transversal, then I know the angles will be congruent. We've seen that yesterday. I know if I have two lines cut by a transversal and the angles are the same, they must be what? Parallel lines. So when we're dealing with these converses, it allows us to go back and forth. Okay? So again, it's the idea that you've got it in your head that if you've got two angles that are corresponding and they're congruent, lines are parallel. Lines are parallel, you're going to have congruent angles. Okay? So, sort of kind of makes sense in an odd sort of way. Okay. Somewhat. Good. Really, what you need is down here. If the angles are congruent, then they're parallel. Given this picture, okay. So sometimes it's just easier to go and identify what the most basic ideas of it are. Now, if I got parallel lines and I got that picture, then I know they're congruent. That's the way it is. So, let's take a look at some more of this stuff. Okay? So, are these lines parallel? Do they have to be parallel? Why? Okay, so the both angles are congruent, yeah, that's fine, but that doesn't tell me anything about the lines being parallel, does it? So if I want to say that these lines are parallel, what is it that I would have to do in order to make that statement? What do I got to know? What do I got to say? How do I got to identify? What information do you have that justifies that statement? Do you have anything? Isn't this thing right? Isn't just what we did right there? That's it. So, when they ask you to go through and prove something like this, all that you are going to have to do is you wouldn't put down postulate 12. What you would do is write something to this effect. Come on, pen, work. You were working before. No, you're not working. So, converse of what? What is the name of the postulate we just took a look at? Converse of what? Converse of corresponding angles. Sometimes it doesn't work very well writing it out, but that's all it is. That's what you need to be able to state. What allows us to go and state that? Okay. Converse of the corresponding angles postulate says if I've got angles that are congruent and I got a transversal and I got two lines, they must be parallel. That's all it is. Okay. Here's another one. Okay. Again, like what I said before, the best bet is get the if-then part of it and the picture. But this is going to be the converse of the alternate interior angles theorem. So I'll give you a few moments, make sure that you've got that one in your little book. Okay, here we go. Now, I'm presented with this information. I need to prove that J and K are parallel. Now, first one we took a look at was the converse of the corresponding angles. Do I have corresponding angles here? No, I don't. So can I use that to say this is the case? The answer is no, I can't use that piece of information. Okay? I go back here, alternate interior angles. So if I know if I got alternate interior angles that are congruent, then the lines are parallel, according to what the information says. So, is there any way that I can get alternate interior angles in here? How? Well, 2 and 3, yeah, but I don't know what the measure of 2 is. And I can't say it's equal to 57 degrees because the lines are parallel. I don't know they're parallel. How do I know what this degree measure is? Absolutely correct. So if I take 180 minus 123, I end up with what? 57 degrees. So I now know that that's 57 degrees, correct? And because that's 57 degrees, why are these parallel? Well, that would end up being the converse of the what? Alternate interior angles. The converse of it. Okay? Could have I done this another way? What happens if I would have decided that, you know what, I want to use corresponding angles? Could have I found out what this angle here was going to be? Yeah, because that would just simply be 180 minus 57, which turns out to be 123, right? And 123 is here, 123 is there. Therefore, corresponding angles are congruent, must be parallel. There is more than one way of dealing with these things. And depending upon what instructions you're given and depending upon what you see, one person can do it one way, another person can do it another way. Here's another one. After all, I mean, we took a look at alternate interior angles, we took a look at corresponding. Another one that we dealt with was alternate exterior angles. Catching the theme here? That if the angles are congruent, then the lines are parallel. take a look at this. I need to identify both pairs of alternate exterior angles. So, alternate exterior angles means that they got to be on opposite sides, right? And on the outside. So, would one of the pairs be, yeah, good. Would it be 4 and 6? Would it also be 1 and 7? Okay. Now, I know which ones are alternate exterior angles. How can I prove that these are parallel lines? I don't see any numbers there except for 1, 2, 3, 4, 5, 6, 7, and 8. I don't see no degree measures. So what is it that can allow me to say that these are parallel? Yes, ma'am. Oh, I thought you had your hand up earlier. What? Never. Those little curvy things in there. Yes. No, protractor is a never. Never, never, never a protractor. No way. Bad idea. Bad idea. Because it's measuring, and whenever we're measuring, there's always a chance of error. Okay? Our tools are not perfect, but the rules are perfect. I mean, there is no question whatsoever about this because we know what they add up to. If we measure, we could have a little bit of an error. So we know that this here and this over here are congruent. We know that these are alternate exterior angles. So that means by the converse of the what? Alternate exterior. Boy, my pen is really messing up. Okay, yeah, I know exactly what you're thinking. It's operator error. Alternate exterior angles. Okay? By the converse of that. That's what allows us to say it. Okay? So, here's another one. Try this. Get that one down and make sure, and like I said, you just have to worry about the if-then part of it. If you want to write down the rest of the stuff in there, by all means do so, but you really only have to worry about the if-then part. Alrighty. So. Isn't done? Oh. Well, guys, do remember that you always can look this back up in your textbooks. You're supposed to read the book anyways. Yeah, I hear that, yeah. So, I need to identify both pairs of same side interior angles. So would that be 3 and 8? 2 and 5. What do you mean you guess so? Are they in between the lines? Are they on the same side of the transversal? There you go. So, how can I state that these are going to be parallel lines using same side interior angles? Yes, sir. No, that should be closed. You know better than that. So, oh, don't even, no. We know that is congruent to that, correct? So I could do this by alternate interior angles. However, I know that if I add these two lines up, that these add up to 180 degrees, correct? So that means this here would be whatever 180 degrees minus that is, right? And if these two are the same, wouldn't I take this and add that together and get 180 degrees? What do you mean possibly? If 5 plus 8, mind you we're talking about the angles, is equal to 180 degrees. Here, I'll put the little, we're talking about the angles, not the numbers or the values, but angle 5 one more time. So, angle 8 and angle 5 added together equal 180 degrees. So, would that mean that angle 3 plus angle 8 would also be equal to 180 degrees? Yes? No? Yes or no? It either is going to work or it's not going to work. It's not a maybe or a guess so. So, goes to 180 degrees, and because we've got the same side interior angles adding up to 180 degrees, then I can state that these lines are parallel because of that rule. So again, it's knowing what the rules tell us. So, what I am going to do is I am going to give you, I'll give you a minute, and I want you to do A first. Minute and do A. A. I don't know, you wrote it down. I do believe that was the converse of corresponding angles, was it not? So, are they parallel? Why? Okay, but that's fine that they're the same temperature, but why are they parallel? What is the reason? Yes, sir. Yep. And that's all that it's going to be, so that would end up being the converse of what? Corresponding angles, and if you want, put theorem in there as well. Oh, postulate? Okay. Corresponding angles theorem, there's, yeah. Depends upon how they want to identify it, but we'll just go with that then. So, corresponding angles. So, if I take a look at B, I'm going to give you 30 seconds and see if you can figure that out. What do I got to do? So, what do I need to know in order to make this work? Yes, you are correct. Specifically, the math that tells me what? Yeah. What do I need to know? Do I have enough information right now? Okay, I've got enough information, but what? Okay, there's no rule that does this, is there? Which one? But I don't have interior angles. I have an interior angle here and I have an exterior angle there. Okay, so I got to take 180 minus 111 and I end up with what? Okay, so if that's 69, so now I know what that angle measure is. And now that I know what that angle measure is, and I can't state it because it's 111 here, I need to know that it's going to be. So, now I can say by the converse, by the converse of what? AIA, alternate interior angles. Okay. I'm going to give you 90 seconds and I want you to figure out C, D, E, and F. Okay, I'll be generous. I'll give you 2 minutes. Concentrate on what you're doing. So, that puts us up for Hannah. So what are the alternate exterior angles in this figure? Good. And what's the next one? You betcha. Okay, that worked. Let's see, that gets us at Caleb. Okay, so what do we got here? 3 and 8, 2 and 5. Okay, so then we end up Jacob and, right? Yeah. So, and he's not here, of course. Okay, so we get what would be your bet then? If we know that 2 and 6 are congruent. Obviously it's going to be a converse, right? But a converse of which one? What, okay, what are 2 and 6 to each other? Okay, so what do we say that they are if 2 and 6 are in the same place? What's the word that we use for it? Not congruent, but oh, those of you in the peanut gallery, help out. What's the word that we want? What? Corresponding. So, this is going to be corresponding angles. Okay? Converse of that allows for it. So, I'm going to give you a minute. I want you to think about these two. Alrighty. So, what describes this, Tristan? So if I've got Spear Boulevard crossing Fox, crossing Elati, crossing Delaware, what do we call something that crosses a transversal? Yes. Well, make sure that you have it written down in your little book so you know what the transversal is called now. I see. So, then you always must go back and take a look at your data so that you are able to come up with the correct answer. So, Hope, can I prove that Fox, Elati, and Delaware streets are parallel? Well, first question is, do we have information about how those lines intersect? I've got this here, it says 33. I got this here that says 33. I got this here that says 33. So, out of the angles that we've looked at, are they corresponding? Are they alternate interior, alternate exterior, same side interior? Incorrect. Corresponding angles. Okay? By the way, guys, when I'm asking somebody, I expect them to answer, not the rest of you. So, these are corresponding angles. Why? Because they're all in the same place. 33 degrees here, 33 degrees here, 33 degrees here. So, I can go and identify this by the converse of corresponding angles. It has to be parallel to each other. Why? Because a transversal is going through at the same degree measure for every single one of these. So, we need to make sure that we identify those types of things. Okay? So,